We've been talking about implicit differentiation, being able to find the derivative of, of a relation that's not defined explicitly, defining y in terms of x, but something that's using x and y's together in a more complicated fashion. We took a look at a fairly simple example in the last video where the x's and y's were all nice and separated from each other. In this video, we're going to take a look at kind of where they're merged together and see how things become a little bit trickier, but we're still in charge of it. All right, so let's say, here's what we did in the last video. So we're taking the derivative of both sides of this equation with respect to x. And so this just becomes the derivative we're used to. Whenever we're dealing with y as our variable, we need to kind of do it the way we're used to and then add in this factor of dy dx. And as I explained in the last video, it's a little bit of an example of the chain rule, because when we're taking the derivative with respect to x, y, we need to think of that as a function of x. And so that is kind of our inside function, okay? Here we've got x squared y cubed is equal to 1. So this is a little bit trickier, and let's say we want to find the slope of this curve at 1, 1. So x is equal to 1 and y is equal to 1. All right, so let's take the derivative of both sides of this equation and see that we don't need to separate the x's and y's. Sometimes we can't, and so that's going to work out fine. So here we've got the x's and y's together. We're multiplying a term with x's and a term with y's. So what do we use in calculus when we want to find the derivative of two things we're multiplying together when we know the derivative of those two things? It's the, when you multiply together, you get the product. We need to use the product rule. Okay, and so the product rule says that kind of our first function, I hate to use letters here. So let's say that the first function is x squared and the second function is y cubed. And so what's the derivative of these two functions with respect to x? Well, the derivative of x squared is 2x, and the derivative of y cubed is 3y squared. Remember, we need to add in this factor of dy dx. Okay, so the product rule says that we just need to add together these two products. Okay, so taking the derivative of both sides, we have x squared times 3y squared dy dx plus this product here, 2xy cubed, is equal to, be careful, don't put down 1 over here. We're taking the derivative of both sides of the equation. This is a constant, so the derivative of a constant is equal to 0. Okay? So that's the tricky part, taking the derivative. All we need to do now is solve for dy dx. So the first thing we'll do is we'll subtract 2xy cubed from both sides. So that gives us 3x squared y squared is equal to negative 2xy cubed. Whew. Whoops, I'm sorry, 3x squared y squared dy dx is equal to that. Okay, because dy dx is what we want to solve for, and so we just need to divide. So that gives us dy dx is equal to negative 2xy cubed over 3x squared y squared. Whew. And we could cancel out some terms here actually if we wanted to. So we've got a y cubed in the numerator and a y squared in the denominator. So that's just going to leave a term of y, one factor of y in the numerator. We've got our negative 2 over 3. We've got 2 powers of x in the denominator and 1 in the numerator. So that leaves us with 3x in the denominator. So the slope, the derivative with respect to x, is negative 2y over 3x. So this is a good function to know, but we wanted to know at this specific point here, 1, 1, what's the slope of this function? How can we figure that out, do you think? Well, here's an expression in terms of x and y. So to figure out this slope at a specific value of x and y, we just need to plug in that value of x and y. So dy dx at 1, 1 is equal to -2 times 1 over 3 times 1, which is just equal to -2/3. All right, let's double check our work. You can't always do this, and when you're in the middle of a test where you don't have access to other tools, you certainly can't do this, but we've got access to Geogebra. All right, so I'm just gonna really quickly jump over here. And so here's our equation, x squared y cubed is equal to 1, and here's the point 1, 1. So let's zoom in really close on this and see if it matches our prediction that this is looking like a function that has a slope of -2/3. All right, that's certainly enough zooming. So if we go down 2 and over 3, are we going to hit the curve? 1, 2 down, 1, 2, 3 over. So in fact, this looks like it does have a slope of -2/3, just like implicit differentiation told us that it would. So this is an example of how to solve a harder problem where the x and y's are multiplied together in a single term. So it's just a matter of using the product rule to make that happen. So I'm feeling kind of confident about this. So in the next video, we're going to go back and solve the original problem that we had to introduce this topic.